Hello, everyone. Let me share my screen. One sec. All right. Katie, can you please confirm? Can you see my screen?
Yes, confirmed. You're good to go.
All right. Thank you. All right. So in today's session, I'm going to cover how Aviatrix Secure Cloud Networking Platform provides the proven solution to SaaS providers with the enterprise class cloud networking, security, and operations. I will cover the typical challenges we have seen working with SaaS providers, especially when it comes to the networking and network security, as well as the visibility portion of it. And some of those challenges, as mentioned in the slide as well, like overlapping IP, service insertion through next-gen firewall, such as Palo Alto. And I will also have a reference architecture later in the presentation today, which I'm going to show you guys. And hopefully, if you have time, I'm going to also show you my demo environment. So I have a pack agenda. So let's get into it. All right. So for those of you who don't know about Aviatrix, Aviatrix is a provider of advanced grade networking, security, and operation in public cloud. We build the architecture that you can repeat in any cloud, any region. So how Aviatrix can help? So Aviatrix can help you to achieve your business goals by building the right architecture that will accelerate your cloud migration journey, provide deep visibility, improving your network and security posture that would require an audit and governance, and also helping you to close the skill set gap that you need in multi-cloud environment. Here's a list of our customers who's currently using Aviatrix solution. And you can see some of those customers are SaaS providers as well. All right, so with that, let's take a look at Aviatrix architecture first. So I'm gonna go into the high level first with the components, and then we'll deep dive into the individual multi-cloud architecture. So in your screen, you can see for any distributed architecture, we have a controller, right? So at number one, you can see that's an Aviatrix controller that you can spin up from any CSP marketplace, AWS, Azure, GCP, Oracle, or Alibaba. So that controller is the brain of the operation. That is basically managing the control plane as well as the management plane. And through that controller, you can spin up these gateways. So at number two, you can see Aviatrix gateways. These are software routers, which providing you the advanced network and security capabilities inside your VPCs and VNet. So these router spin up through controller inside your VPCs and VNet. All right. So controller also have an API integration with all of your CSPs like Azure, AWS, and you can see we support all 5 CSPs, as well as we also have an API integration with Palo Alto. So I will deep dive into later slides how controller will automate your Palo Alto next-gen firewall in case VM series and automate the entire complicated process. So these gateways at number two, these gateways are also providing a telemetry and feed in the form of NetFlow and so on to our Copilot. And Copilot is our day 2 operation visibility tool, by the way. So on the right-hand side, you can see some pictures. Those are coming from our Copilot. All right. So as we saw in the previous slide as well, we build the same repeatable architecture, right? So in AWS, Azure, GCP, Oracle, Alibaba, you can see those gateways. These gateways here, right? They are software gateways that sits inside your VPC and VNet, and build hub and spoke kind of architecture, right? So these gateways build a secure connectivity in high availability fashion within the same region, across region, or in multiple cloud. So if you notice, we have same hub and spoke kind of architecture in multiple region in case of AWS, or if you are in multiple cloud, Azure and other clouds, the same repeatable architecture will carry along, right? The other important aspect of it is it also provides you the end-to-end encryption. So by default, everything is encrypted. So the traffic coming in from the on-premises or between our gateways, everything is encrypted. That encryption is IPsec, and it's multiple tunnels that we use for high availability. So the multi-cloud connectivity in case of between AWS and Azure or GCP and Oracle, right? So that multi-cloud connectivity can be over the internet, or it could be using private interconnects, such as Direct Connect or Express Route, or maybe if the SaaS provider is using providers like Megaport or Equinix. So that connectivity can be over the private link as well. All right. The other thing is, if you can see, we have a Terraform, right? So the entire architecture you can see here that can be automated using a single Terraform module, and you can integrate, or you can also use APIs, or you could use if you have existing CI/CD pipeline that can be integrated as well. Now, when it comes to security, as I already mentioned, everything is encrypted, right? The other thing is, which is also very critical in this architecture, the VPC to VPC and VNet to VNet, everything is encrypted. We also have a service insertion. You can see that firewall. That's in this case, that could be your Palo Alto VM series firewall, right? And controller automate the entire firewall deployment, which is consistent across multiple clouds. So you don't need to reinvent the wheel. For example, if you're in AWS and if you move to GCP or Azure, we have consistent process since everything is coming from controller, and controller take care of all the complexities at the back end. From a traffic flow point of view, our service insertions support all type of traffic flows like east-west, VPC to VPC, VNet to VNet, or ingress and egress traffic going towards the internet or coming from the internet, or traffic coming from on-prem to accessing your application in VPC. So the traffic flow, and we'll go into more details in later slides, but that's how the traffic and service insertion gonna work. The transit gateway in the middle, these middle tier, you can see these are, we call it transit gateways, and it will forward the traffic to the firewalls. We also have a multi-cloud segmentation, right? So the color coding you can see on top of VPCs, they are a representation of our multi-cloud segmentation. So we support both network level segmentation, or we also support micro level segmentation, which is our intra level segmentation. All right. So the next thing, which is also very critical, is visibility and control. Since we are building a new data plane with the help of these software gateways, right? This distributed data plane will also providing you the deep visibility into your multi-cloud environment. So at the top, you have some screenshots of our Copilot, which gives you the day two operation visibility and gives you the visibility and troubleshooting tool that help you to minimize the MTTR as well as meeting your strict SLAs. It also serves you the compliance and governance tool as well, since everything is logged, right? So you can see who's talking to who with deep visibility, like packet capture inside your VPCs, and whatever traffic is passing through these gateways, the Copilot has all of those logs and information. All right. Now let's switch to the SaaS provider common challenges. So as I explained earlier, the Aviatrix, we are taking care of advanced networking and security, network security, and providing you the deep visibility. With the Palo Alto, it's providing you the next-gen firewall features inside your cloud, and you can deploy the VM series to get the desired security like deep packet level inspection and DLP and so on. So when it comes to SaaS provider common challenges, and as mentioned by Raj and Jeremy as well, one of the critical thing is deep visibility, right? And also how you can secure the connectivity as well, right? So as we move our application to public cloud, we need to move our customer and partners as well, right? And we need to make sure that connectivity coming from partners and customers, that needs to be flexible, right? That needs to be secure as well. And especially when we have SaaS type of application hosted in cloud, our customers are accessing those applications from anywhere, right? We do have deep integration with other solutions like Palo Alto, DLP, and all of those SASE or SaaS providers. providing you the firewall as a service, as well as the DLP and all of other security intelligence as well. But when the customer accessing your environment, the typical challenge is obviously you don't have control to their environment, right? So there are common challenges with the overlapping IP, right? And also, since we have multiple customers accessing the same application, you need to make sure each of those customers are completely isolated. So obviously you don't want those customers to talk to each other, right? So now let's take a look. I'm going to double click on all of those challenges one by one, and we'll look into the architecture and try to understand first what are those challenges. So the first one is the overlapping IP with the end customers or partners. So in this architecture, you can see at the bottom, we have various customers or various environments. So customer A, maybe this customer A is already in public cloud. Some customers are coming from on-premises branches or some partner side. And this is the cloud environment, and you have some shared services at the top. Those are VPCs or VNet, where your Kubernetes shared services or maybe some other shared services are hosted. So idea here is these customers are accessing these applications hosted in the single cloud or multi-cloud or multi-region environment. So if you notice here, the number one challenge here is they are using the same IP or same seeder. So customer A and branch and all of these are using the same seeder, 10.100/16. And this is a very common use case I've seen working with the SaaS providers. So obviously we need to resolve that challenge, right? So that overlapping use case could be in your environment as well. As a SaaS provider, maybe you have a VPC or VNet that could overlap with the customer environment, and that is also very common, right? So in this use case, you can see we have customer A and B, both are overlap with each other, but also overlap with your hosted environment. So typically, obviously, you don't want, you cannot ask your customer to do the netting on their devices, or maybe they don't have NAT supported devices. Maybe they just have a dummy device that only support IPsec or only support basic networking. So in that case, you need a solution that is flexible enough to take care of all the heavy lifting when it comes to NAT configuration, right? So in this case, we have Aviatrix gateways that can provide you the advanced NAT features like Many-to-One, SourceNet, DNet, and other NAT scenarios that can solve your overlapping IP scenarios. All right. The other use case we have seen, as I talked earlier as well, is the segmentation. So in this case, you can see we have customer A and customer B. We solved the overlapping IP challenge, right? So within adding on the gateway. The other challenge we will look into is the segmentation, or you want complete isolation between customer A and customer B, right? So how we can achieve that? So with Aviatrix, since we support multi-cloud network segmentation, you can see we created a segmentation domain for each customer. So the blue domain is for customer A, and the green domain is for customer B, and they can both access the shared services, but they are completely isolated at the network layer. Now, let's take a look at the another use case here, which is traffic inspection through next-gen firewall, right? So in this use case, we have other connectivity requirement, right? So customer A and customer B, they are coming to you to access your application through private links. So on the left, you can see we have an AWS environment, and this particular customer A, is already in public cloud in AWS, and they want to access these applications through private link, right? So the traffic, the connectivity is through private link. On the right-hand side, the customer B, that customer is in Azure, and they're using the private link as well, right? So in this case, and one of the compliance and regularity requirement is you want all the traffic coming in from customer environment or leaving from your environment has to pass through next-gen firewalls such as Palo Alto VM series. So how you can achieve that? So with Aviatrix Gateway, this is our transit gateway in the middle, we can do service insertion, right? So the traffic coming in from customer A, it will first forward to transit gateways, which is in the middle. And the transit gateway, based on the policy we define on our controller, it will do the service insertion and forward the traffic to one of the available next-gen firewall, in this case, a VM series firewall. And then based on the security policy you have in this firewall, the traffic will dictate either it's permit or deny or whatever the policy is, and then forward it to the destination application VPC or VNet, right? So in this case, we have full next-gen firewall service insertion. In this case, it's kind of like a north-south, but you can also insert the firewall for east-west as well. So for example, between these two shared services, if you want to forward traffic to this firewall, that can also be achievable. All right, so that feature, we call it FireNet. So FireNet is Aviatrix features when we use service insertion. All right, so the next use case here is the high availability, which is obviously very critical, especially when in case of SaaS provider, when the application is hosted and multiple customers are accessing those applications, right? So in this case, you can see we have high available architecture, right? So the same architecture can be available in any cloud, any region. You have connections coming in from customer environment, and those connections you can terminate on other environments as well. And at the top, you can see the shared services. Those shared services can be replicated in other regions. So maybe you have customers in multi-region environment, or geographically, you can terminate those connections into multiple gateways. And by the way, all of those links, you can see everything has a redundancy from a link perspective as well. So it's not just a single link. If one link fails, the traffic can be routed automatically to the other link. And from the other, on the other side, from the other perspective, we also support advanced traffic engineering, right? So for example, if you have a two region and you want one region to prefer over other, with the advanced traffic engineering through BGP, such as local preference areas path, you can achieve your desired path as well. So that can also serve from a high availability and redundancy point of view. All right, so the other challenge, I know I have a lot of use cases I really want to go through with you. If you have any question, feel free to put your questions in a Q&A session as well. All right, so in this use case, you can see we have various connections, right? So obviously, it depends on customer environment. Maybe they're using old devices which doesn't support route-based VPN, right? So maybe they only support policy-based IPsec VPNs. So you need to be flexible enough to accommodate all type of connectivity. So with our solution, our gateways support both policy-based and route-based IPsec VPNs. And in this case, you can see various customers, and each are coming from a different IPsec requirements. All right, unidirectional traffic flows, which is also very important in case if you deploy the firewall in public cloud. And by the way, in the architecture, you can see just one firewall here. But imagine we support up to 20 firewall, 10 firewall in each AZ in total in a single VPC or in single transit. We support up to 20 Palo Alto VM series firewalls. That gives you approximately 75 Gbps of throughput. So when you have active firewall, obviously you need to make sure the traffic flows be symmetric, right? So in this case, Aviatrix Transit Gateway, this gateway is making sure the traffic and maintain a session and forward to the right firewall, right? So with the session maintenance, it know the stickiness with the same firewall the traffic is already passed through. So that's how the Aviatrix gateway, the transit gateway in this case, maintain all of those connections, which is, by the way, a challenge when you try to do by yourself, in case you have active firewalls and you have to maintain sessions and between the firewalls. All right. Now let's take a look at whatever use cases we saw in the previous sections. Now let's consolidate all of those and see with the architecture where those use cases landed, and how we can merge all of those together. The number one use case here, as we already saw, you can see at the bottom, we have various customers connections. It could be route-based, it could be policy-based IPsec VPNs, and we can support and handle all of those on our gateways. those connections could be a private connections as well, right? So the customer, it's very sensitive, maybe a financial customer, and they don't want to rely on internet or IPsec over the internet. They want to use the private circuits like maybe Direct Connect, Express Route, Cloud Interconnect, Fast Connect, or it could be through Megaport or Equinix as well, right? So in this case, we also support those type of connections, and we have a native integration with the native construct in each service provider, in each CSP in this case, and you can have connections with that as well. We do have edge gateways that you can spin up in your on-premises environment. Those edge gateways are in the form of virtual, it's a VM that you can deploy in the ESXi or KVMs in your on-premises world, right? That gives you the high performance encryption, right? So this is applicable when you or your customer are using Direct Connect or Express Route. And as we know, Direct Connect does not give you, although it's a private connection, but it doesn't give you the encryption. But if you or your customer interested to encrypt end-to-end, even the traffic leaving from the data center and accessing the application in a cloud, you can deploy these gateways, and that gives you the encryption, which is line rate. Like, for example, if you're using 10 gig, and as you may know, IPsec is limited to 1.25 Gbps. So although if you try to encrypt your 10 gig link with IPsec, it's limited to 1.25. But with our gateways, we'll build a multiple or redundant IPsec tunnel that give you the line rate performance. All right, as we already saw, we can support the SNAT, DNAT configuration to handle the overlapping IP, and this architecture is highly available. We can have multiple gateways, we have multiple links available, and we have the DR supported architecture. You can spin up in the another region, or the same architecture can be in multiple clouds. All right, now I built a demo topology for you guys, just a simple topology just to understand what are the typical challenges or requirements are. So in this topology, first of all, on the left-hand side, you can see we have customer A and customer B. Both are using same CEDR, 10.10.00/16. On the right-hand side, I have a SaaS environment. This is SaaS provider environment, a very basic environment. You can see VPC A and VPC B at the bottom, right? Those VPC and VPC B, so VPC A is dedicated for customer A. That is just dedicated for customer A environment. And VPC B similarly is dedicated for customer B. So in the middle, we have shared services. So both customer A and customer B wants to access some shared services. And you want, obviously, as a SaaS provider, you want secure and reliable connectivity from your customer. So number one, as you can see, we have an overlapping IP. We need to solve this challenge. And to solve that, we need a simple NAT configuration. We don't want any NAT configuration at customer side. The second requirement is the segmentation. We want customer A traffic and customer B traffic completely isolated. The third requirement is the end-to-end encryption. The traffic leaving from customer A side and accessing the application in SaaS provider, everything in between should be encrypted. The fourth requirement is due to compliance and regulation, you want to insert the next-gen firewall. So you have all of those application level, DLP, and all of those next-gen firewall features available. Last but not least, you also need full visibility. You need to make sure who's accessing your environment, what's the latency. If you need to do any deep packet inspection or packet capture, you need all of those type of features that you can use to do your day-to-day operation. All right, now with this architecture, with this requirement, let's build an architecture with the help of Aviatrix. So you can see in the middle, first of all, we have Cloud Access VPC A. You can think of it as a landing VPC where we're going to terminate our connections. So at the moment, we are considering IPsec tunnel, right? So if I can, so customer A is using a router that support IPsec, right? We terminate an IPsec from this site to Aviatrix gateway in one of the VPC, a landing VPC, or you can call it like onboarding VPC, right? So since they are overlapped with the environment, we have to do netting. So we are doing a one-on-one netting. So we assign some remote virtual seeders and local virtual seeders so that this IP, when it accesses to this environment, it will translate it to some virtual IP. Okay. In the middle, you can see we have a transit VPC, firewall transit VPC with Aviatrix transit gateway, and we have Palo Alto VM series firewall. Okay, that is the another requirement, that the traffic coming in from customer, it has to pass through these firewall. And then you can also see the shared services VPC and segmentation, right? So each VPC-A, each of these connections or communication coming in from each environment is completely isolated. There's representing some color coding here. The traffic coming in, it will not interact or not access to the other environment of customer B in this case. Okay, and on top of it, as you know, as I already mentioned, these gateways are providing a feed to a Copilot, which is a day two operational visibility. Now, let's take a look at the NAT configuration, right? So you can see this host is trying to access application here. Since we are using the virtual seeder, the request will go to 164.2.26, which is basically this IP. We only translate the network portion of it. The host portion is still gonna same. It's gonna access, is gonna go to our gateway, and then it will translate and do all those NAT magic. And then when the traffic initiated from SaaS provider environment, again, the traffic is destined to the virtual IP, and then gonna do the translation here and then access the environment. All right, those color coding, you can see we put customer A in a red segmentation domain, and green for customer B, and yellow for shared services. So what is going to happen with the connection policies, right? So we created these segmentation domains, and with the help of connection policies, what we did from controller, we basically define a policy that a red can talk to blue, red can talk to yellow in this case, but red cannot talk to green. So only red and green can talk to yellow, and yellow being a shared service, right? That's how the segmentation policy works from controller. And I will show you in a bit as well. And also these dotted line representing the traffic has to hairpin through our service insertion, through the firewall, and then forward it to the destination. All right, I know we have just 10 minutes. Just quickly wanna show you our demo environment, especially with segmentation feature. All right. So from a day two of visibility perspective, as I was mentioning earlier, our Copilot is day two operation visibility tool. The demo environment that I showed you guys, I already deployed. So this is our Copilot, and this gives you the real-time topology as well, right? So you can see the real-time latency, right? So between customer A and transit, you can see we have 0.64 milliseconds. And this customer A, this is the IPsec tunnel or site to cloud tunnel from customer on-premises environment to Aviatrix gateways hosted in AWS in this case. All right. You can also do the troubleshooting. If you go to diagnostic, you can do all of those troubleshooting tools that you used to have on-premises. You can also do the packet capture, real-time packet capture if you have to investigate what type of traffic is coming in, and you can download those packet capture in a PCAP format as well. All right, so I want to show you this segmentation feature here. So remember, we created 3 segmentation domain, one for customer A, the other one is for customer B, and then the shared services, right? These are the segmentation domain we created. And if I'll click on logical view, so these are connection policies that defines who can talk to who. So for customer A, in this case, right, they can talk to shared services, but they cannot talk to customer B in this case. So both customer A and B can talk to shared services, but not to each other. So if I look at it from a different view, you can see the shared services can talk to customer A and B, right? So we also talk about the flow IQ and other features that help you to understand what's going on in your day two environment, right? So this tool, I'm not going to go into other features. We have tons of other features, and you can see from a menu options here from Copilot, it provides a lot of options and a lot of visibility that you would need to from a day two operation visibility point of view. Let me switch back to my presentation. All right. All right. So as a recap, we look into the multi-cloud architecture, how Aviatrix help with the SaaS providers, common network and security challenges. We look into overlapping IP and advance some of those net features that we support to overcome the overlapping IPs, right? But also security challenges, how you can, when you need to insert the next-gen firewall in your traffic flows, as well as the network, multi-cloud network segmentation, right? And last but not least, the visibility portion of it, how you can troubleshoot it. So these are some additional resources that you can look into it, docs@aviatrix.com for additional documentation, as well as I also put a link for reference architecture, the validated design for SaaS providers. So feel free to connect with us. And if there is any additional question, feel free to ask. Thank you. Any additional questions, guys?
Asad, did you have anything else that you wanted to talk about before we move on?
Yeah. So one of the question I have it here is the supported connectivity options, right? So when you are in a SaaS provider business, obviously the customers can come into any connectivity type, right? So you need to be flexible enough to support all of those connectivity options. So what I've seen, especially with the service providers or SaaS service providers, the connectivity option, sometimes it could be an IPsec tunnel, just a simple IPsec tunnel. That's a most typical connection to start with. And then it could be a private link as well, as we saw in the reference architecture as well, right? So it could be a private, maybe your customer is already in public cloud and they want their application to access your SaaS application, and they don't want to use a private, they don't want to use a public internet or any sort of new feature. They want to use a cloud native private link so they can access your application. So private link is another thing. And we also look into the private connectivity options, right? Direct connect or express route as an example. This is applicable when the customer is very sensitive. They don't want to use the private links, or they don't want to. They have a lot of throughput requirements. Maybe they have gigs of traffic they are expecting. So you need to flexible enough to accommodate all type of connectivity options, right? So I just want to double click on it. One of the architecture that I showed you guys earlier. Yeah. So with this architecture, you can see we support all type of connectivity options, right? And one of the feature, I know there's another question regarding the segmentation, right? So our segmentation, we support two types of segmentation today. So the first segmentation is the network segmentation, right? So network segmentation, let me show you here. So the first segmentation, we call it macro level segmentation or network level segmentation. So those color coding you can see, right? So we are segmenting the entire VPC into one segment. So that segment in this case is a red segment, or you can name it whatever you want. So customer A is red segment, customer B in green segment in this case, right? And obviously if you have a shared services, I put it into green segment. So in this architecture, we just had 3. So this is the network level segmentation or VPC level segmentation, right? We also support micro segmentation. So micro segmentation is, we came up recently, that segmentation is intra VPC or intra VNet. So what if within VPC A, for example, right? So I do have multiple applications, right? And I want to segment those applications. So for example, if you have web servers and databases inside your VPC A, right? And you want to segment those into different security domains. So we call it application domains. You can create application domains and between web and database, for example, and you can create a policies. And you can also insert a firewall in between as well. So for example, in a same VPC A, we have 2 groups of application. And by the policy or by the security policy, you want those 2 application domains, the traffic needs to be forwarded to the next gen firewall. That traffic flow is also supported. Or if you don't want to insert the firewall, you can simply have 4-tuple or 5-tuple based policies that you can define through our controller and implement your microsegmentation. All right. I guess that's about it. If there is no additional questions.
Okay, great. Thanks, Assad. So is that the conclusion of your presentation? Just want to confirm.
That's right.